driver, including hardware and software design. This part of circuit just the same as the previous. First, we will talk about how to the work principle of this module, LED, very simple LED module. So let's first analyze some working mechanism of this LED. First, I will play a video. I already recorded this video, so let's see it. This is a LED, 8-segment LED. There are two kinds of LED. One is common anode, and other is common cathode. The difference is driven by positive voltage or driven by low voltage. We will see the difference later. Here, we label the different segment as A, B, C, D, E, F. Let's see. This is A. This segment is B. And here is C. And this segment is D. So every LED is the same. And here is E. Here is F. Then H. Here is H. A, B, C, D, E, F, G. Here is G. And H is DP. That's a digital point. But in this module, it seems that the DP is not exist. But I still need write DP here. In our program and hardware, we just ignore DP because it haven't DP. So for this LED, it's a common cathode. So here is cathode. If I drive this pin high, A will bright. We can see. This is common anode. This is a common anode LED. Every pin need to add a resistor. If you don't add a resistor, the current will too large and the LED will be damaged in very short period of time. So we need to add a resistor. In general, according to the experience, you can calculate the current. The maximum current is 20 milliampere. 20 milliampere. Yeah, you can see here. A is this pin, then B, C, D, E, F, G. We try to let's remove it. This is B. Then C. Here is B. Here is C. Segment C. Okay. Segment D. Segment E. F. H, G, here's G. So next we can learn how to drive common cathode LED. The program should, the hexamer should be reversed. I copy a VCC to this place. 5 volt. The default is 5 volt, so I just place here. A. Okay. Then B. After you're familiar with the mechanism, we can draw the schematic, hardware schematic, and then we can program. C. E. No, here is G. Okay, I will not illustrate every pin. So next we will analyze how to encode different digital number. Zero. If you want to display 0, so A, B, C, D, E, F should turn on, and G should turn off. So we can try to connect these pins. Okay, this is 0. So next we can try to encode. For number 1, we just need to turn B and C. Turn on B and C. Let's try. I just connect B and C. Disconnect A, then B and C. Yeah, no. Here is 1. Then 2, A, B, C, G, E, D. A, B, G, E, D. This is 2. A, B, G, E, D. Here's 2. Oh, it's wrong. Okay, right now it's 2. So next we will encode this different number. First, we will list each segment A, B, C, D, E, F, G. Separately. Then we will assign different bit to different segment. A is corresponding to bit 7. B is corresponding to bit 6. So this is 1 byte. 1 byte consists of 8 bits. So each bit have a segment.
你不是在打电话吗？
Then from 0, 1, 2, 3, 4, until 8, 9. Let's analyze how it can work. For 0, just G is shut down. So every other bit except DP bit, because DP bit here does not exist, so DP is always 0. G is 0, DP is 0. Then for number 1, only B and C is turned on. Other bits are turned off. For number 2, A, B, G, E, D. So A, B, G, E, D is turned on. For number 3, A, B, C, D, E, G. A, B, C, D, G. E and F is turned off. Number 4, F, G, B, C is turned on. F, G, B, C. Number 5, A, F, G, C, D. B and E is turned off. Number 6, only B is turned off. All other segments are turned on. B is 0. Number 7, A, B, C is turned on. Number 8, all the segment A, B, C, D, E, F, G is turned on. Number 9, only E is turned off. Okay. Next, we will try to translate binary to hexadecimal. There's some problem here, so I have to change because this is MSB, this is LSB. So here is FC, not 7C. If you feel inconvenient, you can use calculator. Set it to binary, then just import this binary inside this calculator. Then it will change to hexadecimal automatically. In this way, you needn't think it by yourself. Just use a calculator. Binary. Hexadecimal. If you want to display other character, you can still add some other encoding. But here we only have a digital number, so we needn't other character like A, B, C, D, E, F, G, H, I, J, K. This we needn't. Next, we will try to connect this LED to our processor. First, let's remove the LED on the example. We move LED to this place. Then we will connect the wire to processor. This is common anode LED. The first LED is common cathode. Here is the next is common anode here. So at the time you buy LED, you purchase, you buy the LED on the market, you should decide which kind of LED you will need to buy. You should select the correct LED just as you design purpose. Next, we will try to drive the first LED. Let's save the project. we will start a queue. We will create a new project. So first, we need to create a directory. We name it as segment 7, SEG7. This is a directory. And the project name, you can select any project name you like. Save. Then select the processor. We select Atmel MC 8051, 89651. It's the same. It's include each square room inside its internal body. Then we create a file. We have only one file here. This is a start file, but we need a C language file. So we will add the file name seg.c, an empty file, to the project. Then only after you add the file to the project, this seg.c file can be used in the project. Otherwise, compile will be failed. So you must add this seg.c to the project. Okay, here is a framework. We define a data array, char, segment. This is a data array. This data array includes all the encode we defined just now. So we will copy all these hexagonal number to the data array. This is 0, 1, 2, 3, 4. So we can add one by one. We compile, no error. Okay. Next, we will add a while one iteration, rotation. We define a function, myDisplay. And the char. So this is the input parameter. And in the body of the function, we just assign P0. P0 is P0 to this data array. The content of this data array should be assigned to the P0. So P0 means port 0. On the schematic, you can see the port 0 is connected to the segment to this LED. Okay, we just call P0. Okay, my display. I import a parameter. Import a parameter here. Compile it. Then generate hexamer. We need to generate hexamer. Output, you select this generate hexamer. Okay, it's generated. Then we upload the hexamer. Run simulation. Oh, there's some problem. It seems don't work. So we need to find why it can't work. It don't work. Why it don't work? We need to use a meter to detect the voltage to find the problem. Add a meter. Probe. Here's a probe. We add 2 probe. Then we debug again. We find that the voltage is quite lower, 1.6 volt. So it can't drive this LED. We need about 5 volt to drive this LED. At least 3.3 volt. So we need to find a solution to solve this problem.
对，对，是。
We need to add a driver because the processor can only drive very lower positive current. Each pin only about 2 milliampere positive current. It can drive only 2 milliampere, but it can sink about 20 milliampere current. So I will add a driver. This is 74 series, 74HC04. This is a NOT gate. NOT gate. I add 8 NOT gate in this place. I arranged 8 NOT gate in this place. I still need to drag the LED outside. So connect the wire. Okay, let's try again. Because I add a NOT gate, so I need to invert this encoder. So in front of this area, I add a NOT sign. So let's debug again. Oh, it seems don't work properly. Let's see what is the problem. We can find that the number we defined is not corresponding to the hardware connection. So let's first check if the code is correct. Then not it's correct. The code have no problem. So the problem is exist in hardware. We need to revise the hardware to exchange the wire because we have connect the wire in the wrong order. So we need to change the order to make the wire consistent with our code. So the order is reversed. You can find here, the order is totally reversed. I need to change the hardware. The wire need to delete and change the order. Okay. Next, I will change the order. You can see in this picture, I have changed the order. P7, port 7 is connected to A. Port 7 is to A because here, A is bit 7. So we change the order. Then bit 6, here is bit 6. P6 connect to B. So here is B. Okay. So each bit is converted, inverted. Let's try again. Now I add a parameter 0 here. I compile it, build. Then I load I load this. Okay. I debug. It works. Then let's try to display another number. I change it to, for example, 5. 5. Let's compile. Build the target. Then debug again. 5. Okay, it's good, very good. Next, we will move this function to while. Then add a delay. My delay, DLY. DLY. I add a delay function here. Delay. Int. I define two variables. 4. Okay. DLY. I change it to DLY. So roughly, it's delay not very accurate. So we just demonstrate how the LED is working. So I add a delay. Otherwise, it will display too quick. You can't see it very clear. Here I define the int. My number. I define a variable, my number. Then I add a 4. 4. Then I replaced I insert I to this place. Compile it. Build. Oh, there's some error. Oh, sorry. I need to define I. So I change it to I. Okay. Build. Still delay. Delay my delay. So here we define a delay. Int DLY. For example, 100. Okay, compile. Build. Another area. My display. So M display, my display. Copy it here. Okay. Build. Syntax error. Oh, like a comma. Okay, no error. Right now, we will upload and debug. Run. Zero have some problem. So you need to change the code. Maybe the code have, let's check it. 0 means BC. So let's check it. No, 1 means BC, B and C. So this is, here is not 30. 60. So we need to change it to 60. Okay. We change it to 60. Oh, we launch it again. Stop. Start. Okay, it's correct. I illustrate the whole procedure of hardware design and software design based on this very, very simple demonstration. The purpose of failure is to demonstrate during the practical development, you will encounter a lot of problems. So you need to troubleshooting where the problem lies. You should need to find the solution to solve the problem. Then, during the software programming period, always encounter a lot of compile error. You need to find the exact error position and correct those error. And then, even in the end, the device is working properly. So next we can drive this LED. This is different with the previous one. You see, the previous one we have a NOT gate to drive the LED because this NOT gate have enough drive capability for positive current. However, the drive capability for processor is very weak, especially for positive current. But for negative current, it can generally drive about 20 milliampere. So the sink current, it have enough capability for the sink current. In this place, we needn't any NOT gate because it have enough drive capability. So next we will try to program this. We program it. Let's see which port. P2. Okay, this is P2. This is P1. This is P2. Okay, let's define my display 2. I define another. This is for P2. Just for P2 LED. Here is for P0 LED. Okay, P2. We just remove this NOT sign. So here we add a P2. P2. My display 2. I need to add my display 2. Okay, my display 2. Okay, let's try. Compile, success. Stop. Run. Have a problem. So you need to solve this problem. Why it can't display correctly? It's very simple. The first is common cathode. Here is common anode. So there are two kinds of solution. One is just revise this encode hexamer number. And the other solution is to change the outside. So this is the homework for you. I like failure. This failure is very is an essential point for you to improve your technology. So today we just talking a very simple LED driver, which is related to LED encoder and the internal mechanism of this LED. However, if you want to add some more LED together, for example, 3 LED, 4 LED, it's also not very complex. We can add, for example, 3 LED. From the perspective of hardware, we can see. I just teach you the principle of change the hardware. You needn't change other place, just the hardware. I copy it, copy, paste. The second LED, the third LED, you can just add. Then connect the wire from this one by one. You can connect the wire. I will not connect each one. You can do it by yourself. But the most important, you can connect here, for example. Here is connected together. Here is connected together. The most important thing is that to select this terminal. So we need to select this terminal. How to select? I also can use a transistor. I can use transistor. Do not use this NOT gate. NOT gate haven't too much capability to drive the high current. If this LED have 8 segments are turned on, if each segment consume about 20 milliampere, 8 segment will consume about 160 milliampere. So if you use this NOT gate to drive, the NOT gate will damage it. So we need a transistor. Place a transistor. We need to place a transistor. Place a transistor here. Okay. Here's a transistor. Then this is connected to transistor. Ground. Here I connect to ground. I add a lot of transistor. Each LED add a transistor. Copy. Paste it. Okay, then each transistor I will connect to ground. But the working principle is each time only one transistor is allowed to turn on, other must turn off. So in 1 minute or in 1 second, we can divide the time into different time slices. For example, the first period, I turn Q1, turn this on. The second period, I turn this on. All other include Q1, Q3 is turned off. So only this LED is turned on. In the third period, Q3 turned on, Q1, Q2 turned off. You know, if I decrease the duration, for example, only duration I can decrease to 60 milliseconds. So the change, the switch from one to another will be very quick. Our human eye will not observe the flash. even it changed, because it changed very quickly. Our human eye have a property that it will not sensitive to this very quick change. We call it visual instant preserve. Now we connect the NPN transistor to our processor. However, you cannot connect the V gate base directly to the processor. Otherwise, it will be damaged. So we still need a transistor, a resistor. I add a resistor. Add a resistor here. I just add a resistor to NPN transistor. Okay, add a resistor here. Add another resistor. Copy. Okay, then you can connect this to this pin. I can connect to P. I connect to P1. Okay. Let me connect it to P1 port. Connect to this port. Here, connect to another port.
Shit, zeshajenga system nzima. Umecheki venye amejenga hiyo system.
Okay. I connect 3 PNP transistor to 3 P1 port. So let's see. Connect. Haven't enough space, so I need to pull it. Okay. Okay, I connect all the wire. Next, we will programming. We call the mechanism is dynamic scan. Dynamic scan. So we will display one by one. We will remove. I will remove the second display. I needn't this. We only demonstrate the dynamic scan 3 LED together. I will display only display 1, 2, 3. The first display 1, second 2, the third 3. 1, 2, 3. If I would turn on the first PNP, so here I will turn on the first PNP. When it drive high, positive current will turn on the Q1. So we need to add a define. Add a define. We add 3 define. 3 definition. 1, 2, 3. One is 2. The second LED. The third LED. Okay. The first turn on, the second turn off, the third turn off. Okay, this is 1 condition. Okay, else if equals 1, the second turn on, the third turn off, first turn off. If equals 2, 0, 0, 1. Let's check if it can work properly. Build. Okay, let's check it. Debug. Debug, run. Okay, I will increase the speed, so our human eye will not observe the uncontinuous display. I will increase the speed. I decrease the number, so it's become faster. Okay. Run. Debug. I need to further increase it. Delay. Audio. 1. Build. The problem lies. What's the problem? You should, in general, because this is simulator, you need to test it on the real hardware. So to avoid this kind of problem. So this is not the problem of our software. It's the problem of simulator. Because it's running on our desktop machine. So the simulation is not perfect. We need to decrease it. So in real hardware, you can adjust the speed and make it more quick. So be aware. If you want to see the actual performance of the device, you need to verify it on the real hardware, not on the simulator. On simulator, you only just see if it can work. At least on the logical level, it can work properly. But on the performance level, it can't be evaluated. Next, we can change the display because right now, the display is from 1, 0, 1, 2. So I add this 0, 1, 2. You can, for example, I add a display 1, 2, 3. 3. So it can run 1, 2, 3. This is 1, 2, 3. You can further change the code to make it more convenient for further use. So here you can add a parameter. I can cut it out, remove it to a function. I add a function here. Void my digital number. My digital. Okay. Okay. I passed it. However, you need to define I, int I. Int I. Okay. So int. I only have 3-digit number. So M number, my number. I define a my number. Then first I will split my number. I define the 3 variable to put it into the different place. This is place 1, place 2. So I define the int J, A, B, C. Okay. A equals what? Equals number. Okay. Next, you do it by yourself. B equals what? I will not do it. I will only add 0. You should add by yourself. It's your homework. Your homework. You need to add it. Okay, I only display 1. The highest number, A. So I put it here. A. Next, B, next, C. But you should change the code. So if my digital if I add here, for example, so you can see the first number is 2. Other two number you should do it by yourself. In this place, I just only display 0, but you need to try. Delay. Where is the delay? Oh, GLY. I need to remove the past here. Okay. Let's debug. Run. 2. Okay, 2. Next 2, you should do it by yourself. Let's verify again. If I change the number to 5, 3, 4. So the first number will 5. Okay, the first number is 5. The second and the third number is do by yourself. You should revise the code by yourself. This is the homework for you.